This discussion, we are going to see the basics of structural dynamics. This is actually an important course under the Anna University curriculum for BE Civil Engineering students in 7th semester. So today's discussion, I am going to cover the free vibration of single degree of freedom system. Now let me give you an outline of what we are going to see in this discussion. First, we are going to see what is dynamics. In fact, this is the topic which we are going to see in the beginning, because this is the course on structural dynamics. Then we are going to see the vibrations of systems, because our discussion is going to be on free vibration. Actually, there are two types of vibrations. One is free, other one is forced. Then of course we are going to see what is degree of freedom. Because our discussion is going to focus mainly on single degree of freedom systems. So this is a type of degree of freedom, so SDOF systems. Then we are going to see the mathematical modeling for the degree of freedom, that is equation of motion. So it is equation of motion. There we must compulsorily discuss one important principle called D'Alembert's principle. Then we are going to see that important terminologies like natural period and frequency. In fact, these are some of the important terminologies where we must be careful while discussing about dynamics. Then we are going to discuss some of the standard units, because in SI system of units there are some standard units prescribed for defining the various parameters in dynamics. And after seeing the standard units, we are going to see some of the variation in stiffness, because stiffness is again an important parameter when we are going to discuss about dynamics. Then we will be discussing in the final stage the different variety of problems what we can do or solve in this free vibration of single degree of freedom systems. Now we will start with what is dynamics. To define what is dynamics, we have to go back to our higher secondary physics, where we have already studied something on mechanics. So let me give you an overview of what is mechanics. Now to define this mechanics, we have to go again to this definition of force. We all know force has been defined clearly by Sir Isaac Newton. That is, we have to understand the Newton's three laws of motion. So the first law states, that is, it is actually the definition of force. It is defined like force is that which tries to change the state of position of a body. The body may be either in rest or in motion. So that is the main definition of force. It is clearly given in Newton's first law of motion. Now coming to the second law. The Newton's second law mainly spoke on the formula what we are commonly using for finding the force. That is, force is defined as the mass times acceleration. In fact, many of you will be using F is equal to ma. So this is the important law which is following the formula for force. So there it states like the rate of change of momentum acting on a body is directly related to the external force acting on it. This is what the Newton's second law of motion. And of course everyone knows the third law states every action has an equal and opposite reaction. So these are the Newton's three laws. Now coming to that mechanics, which is directly related with the term force. So mechanics is nothing but the behavior of any body or a structure under the action of an external force. So if external force is acting on a body, how that body is going to behave. For example, we are going to kick a ball. A ball is there, say a football. We are going to kick a football. When you kick the football with a force, the ball will be under movement. So that is the behavior of the ball. That we will call that as a response. So that response of a structure or a body is defined in that is with respect to mechanics. Now this mechanics has been classified into two major divisions. One is statics. The other one is dynamics. Now statics mostly deal with bodies which are under rest, or where the time is not going to play a major role. The time will be, that is, it will not be changing or the body's position will not change with respect to time. Whereas when you speak about dynamics, the body will be under movement and the body's position will gradually change, or the force will change with respect to time. So any change which is happening with respect to time, there we can call the term as dynamics. So now our context is going to discuss mainly on dynamics. So now we can define this dynamics. It is like the behavior of a body or behavior of a system under the action of an external force which varies with respect to time. So here dynamics is varying with respect to time. Now what is this structural dynamics? In fact, other than structural dynamics, we do have many other dynamics. One is thermodynamics, and actually we have fluid dynamics and many other dynamic systems. Now our focus is mainly on structural dynamics. So now I am going to define the structural dynamics, which states like the behavior of any structure, under the action of an external force which varies with respect to time. So with respect to time is the major term which we are going to discuss under the term dynamics, and if it is focused on the behavior of a structure, it is called structural dynamics. Now coming to the next topic, or looking into the today's discussion, that is free vibration of single degree of freedom system. There we must compulsorily see what is this vibration. Then we are going to see the degree of freedom. Now looking into the vibration, any motion that periodically changes with respect to time, or any motion which repeats itself periodically. For example, the common example which people will use to say is the oscillation of a pendulum. So if a pendulum is, what it is doing, so a pendulum is there. If you look into the oscillation of a pendulum, so first moment it will be going to the right side maximum, then other side, next side it will be coming back to the neutral position, then again the pendulum will be going to the left side maximum. So now what is happening here? The pendulum's movement is getting repeated with equal interval of time. So this term is commonly called as any vibration, or otherwise it can be called as oscillation. And when we look into this term vibration, it is classified into two types. One is free, other one is forced. Now what is this free? Now we shall take the same common example of a pendulum. Now you take a pendulum. Pendulum in the sense you need not look into a clock. We can say even a ball tied on a string. You take a string and tie a ball at the bottom and you just try to oscillate it. It is also called a pendulum. So there now we see how to create this free vibration. You give an initial force, like I am pulling the ball towards the right. Now I am just leaving the ball. What is happening there? The ball will be under free movement. It is not subjected to any external force. So it will be under total free vibration. Now this is called free vibration. Now what will be there in forced vibration? So under forced vibration, some external force will be continuously acting on the pendulum or any oscillation system. For example, we shall take the same ball. Now what it is happening? I am giving you an initial tap. So the ball will be under movement. When it is coming back again to the right side, I am again giving a tap. Again it is oscillating. I am giving again a tap. So these are all the good examples of, that is, forced vibration of a vibrating system or an oscillating system. Some other common examples we can say, like you take any structure like a portal frame. So it has got some mass and some column, that is two columns are there and a fixed mass is there. Now this portal frame, if it is subjected to some external force like this, say f of t. Why I am referring here as f of t? Because this force is going to vary with respect to time. That is what we have defined here in dynamics. So this force is going to vary with respect to time. So if the external force is continuously acting, what will happen to that portal frame? The portal frame will be under vibration like this. So the vibration repeats periodically and it is a good example of a forced vibration. Other common examples what we can say is, if an earthquake is subjecting or it is acting on this particular portal frame, that earthquake is a very good example of a forced vibration. Say an earthquake is hitting the structure on the foundation and that structure will be under continuous vibration. So this is how we can define forced vibrations. Now how can we give example for a free vibration on this structure? You give an initial force and remove that force. Now the structure will be under oscillation without any external force. Now that is termed as free vibration.